Moving forward, let's now solve an exam style question which is basically taken from a question bank of the IBDP Math A&I course. And we know that in that course the perpendicular bisector falls in the topic of Voronoi diagrams, which is a special diagram made up of perpendicular bisectors essentially. So let's read this question. The Voronoi diagram below shows 4 hotels in a small town represented by the points with coordinates A, B, C and D. The vertices V1, V2, V3 are also shown. Distances in the direction of X and Y axis are measured with increments of 100 meters. Okay, right. Find the midpoint of AD. So I have 2 points A and D, and my first job is to basically find out the midpoints of AD. So the coordinates are -4 and 4 and D is -1 and 3. So basically when I go to part A, it's basically going to be finding the midpoint of AD. So I'm just going to directly apply the formula. I need to see both of the x coordinates. It's -4 and -1. So add them and divide by 2. So -4 plus -1 divided by 2, comma, and I'm going to see both of the y coordinates. They are going to be 4 and 3. So add a 4 and a 3 and divide them by 2, and basically you get the answer of the midpoint of these 2 points. So basically this is going to be a -5/2. I can call it as a -2.5 because I think decimals are still better than fractions, and this is going to be a 3.5, which is 7/2. So we have found the midpoint of the points connecting A and D, or the line connecting A and D, whatever you want to call it, but we have found its midpoint. Let's jump to part number B. Part number B is hence find the equation of the line that passes through V1 and V2. Equation of the line that passes through V1 and V2. This is basically another way of saying hence find the perpendicular bisector between points A and D. As I said, for those who know, Voronoi diagram is a diagram in which every line called as an edge is actually a perpendicular bisector between 2 points, also known as 2 sides. Okay, so part B is basically asking us to find the equation of the perpendicular bisector between points A and D. So we already know the midpoint, meaning we know the point that lies on the perpendicular bisector. Let's try to find out the gradient of the line AD and then take its negative reciprocal to find the gradient of the perpendicular bisector, and basically we would be then done with our part B. So let us try to find the gradient of AD. So part number B, let's try to find the gradient of AD. It's simply going to be done by doing y2 minus y1 divided by, well, this was a mistake. It's simply going to be y2 minus y1 divided by x2 minus x1, and that is simply going to give us the answer of -1 divided by +3, right? And the gradient of the perpendicular bisector, which is the line joining V1 and V2 in our case, is simply going to be the negative reciprocal of this. So convert it into a 1/3 and then basically take its reciprocal, meaning swap the positions of the numerator and the denominator, and it is going to give us a 3. So that is the gradient of the perpendicular bisector. Next, we are going to write our equation in the form y equals to 3x plus c, and once again we need to insert a point inside of this, and that point is going to be the midpoint. So basically the midpoint of AD was a -2.5, 3.5. So we need to insert this midpoint into the equation of the perpendicular bisector that we aim to find. So this is simply going to be a 3.5 in place of y, that's the y coordinate, is equal to 3 multiplied by -2.5 plus c. So 3.5 is equal to 3 times 2.5. I think that's a minus 7.5 plus c, and c is basically going to be 11. Once we are done, the equation of the line connecting V1 and V2, which is the perpendicular bisector of AD, is simply going to be y is equal to 3x plus 11. And that is our answer for part B. It's always a very good idea to label your diagram as you keep on solving questions. So we know the equation of this line, it's y is equal to 3x plus 11, and we also know its gradient, its y-intercept, the midpoint of these 2 points, which we will not really need from now on, but it's actually a good idea to label all of the things that you keep on finding so that your diagram is updated and you practically know all the information about a diagram which you've already found. Moving on to part number C, the equation of the line that passes through V1 and V3 is this. Find the coordinates of V1. So you know the equation that is of the line V1 and V3. You know the equation of the line that is passing through V1 and V2. You need to find the coordinates of V1. V1 is basically the intersection of this line and this line. And finding points of intersection of two lines basically is asking you to find the answer after solving these two equations simultaneously, because simultaneous equations give us the answer of the point of intersection between two lines, and those two lines are V1, V2, V1 and V3. So let's write down both of these lines, the equations of both of these lines, and try to solve them simultaneously. Well, this can be done through the GDC, but obviously we would try to do it as a method by writing it down. So the first equation is basically y equals to 3x plus 11. And the second equation is basically given to us in the question as y equals to minus 2x plus 6. So that is going to be y is equal to minus 2x plus 6. Okay, and we need to solve them simultaneously. The easiest way is substitution, which basically means equate both equations. So that's going to be y equals to y. It's 3x plus 11 is equal to minus 2x plus 6. You move the x is on one side and the numbers on the other side, basically collecting like terms. So when the minus 2x comes over here, it becomes a 5x is equal to 11 goes over there, becomes a minus 5, and x is simply gonna become a minus 1, right? After that, we are going to insert this x coordinate in any of the equation of our choice, because our question is find the coordinates of the point of intersection, which basically means give the x coordinate as well as give the y coordinate. So I'll do that by basically inserting this x value into y equals to 3x plus 11, and that is simply going to be y equals to 3 multiplied by minus 1 plus 11, and that is going to give me an answer of y equals to minus 3 plus 11. And if I go forward, it's going to give me y is equal to an 8, right? So now V1 has the final coordinates as the following. It's going to be minus 1 comma 8, and that is my answer for part C. And once again, as I have found the answer to this part, I'm going to label it on the diagram. So this is going to be V1, and we all know this point is minus 1 comma 8, right? Let's move forward. As we move forward, the coordinates of V2 are this and the coordinates of V3 are this. Find the distance from V1 to V2, giving your answer to the nearest meter. Okay, so the coordinates of V2 are basically minus 5 comma minus 4. So V2 is basically minus 5 comma minus 4, and the coordinates of V3 are basically 2.5 comma 1. So this is going to be 2.5, sorry, it should be 2.5. So this coordinate should be 2.5 comma 1. And with all of these coordinates given, now I know the coordinates of V1, of V2 and V3. all I need to do is basically find the distance from V1 to V2. I just need to use the distance formula to give me the distance of V1 to V2. So for that, the formula is generally given in most of the formula booklets out there. So let's look at that. So solving part D using the distance formula, which we all know is simply gonna be the difference between the x coordinates, let's call it as x1 minus x2 whole square, plus y1 minus y2 whole square. It's just an application of the Pythagoras theorem. So let's try to plug in our coordinates over here. The difference between the two x coordinates that we find over here for v1 and v2 is basically -1 and -5. So the difference is just gonna be 4, okay? And the difference in the y coordinates from 8 to -4, that is basically something like 12, okay? So 4 is the difference between the x coordinates. It's just gonna be a 4 square. Even if it's a -4 square, we don't really care about that, because after squaring the answer is gonna be a positive answer. So I just like to do it mentally. I don't really like to write down all of the coordinates if the numbers are pretty simple, just like this. This is simply gonna be a 16 plus a 144, and we're just gonna take the square root of this, and it's gonna give us an answer which is 12.649. Now we read a statement about that every unit represents 100 meters or something like that. So I think it's a good idea to multiply it by 100 so that we can get our answer in meters. So it's gonna be 1265 meters if I round it to the nearest meter. Well, I can have decimals, but it's better to round it to the nearest meter because the question actually specifies us to do so. Part number E, given that the distance from V1 to V2 is 783 meters. Okay, the distance from V1 to V2 is, V1 to V3 is 783 meters. And we have found this distance over here. This was 1265 meters. So this is 1265 meters. What do we need to find now? Find the angle V2, V1, V3. So V2, V1, V3. We basically need to find out this angle over here. This is unknown. Okay. Let's try to see, is something else given to us? So the distance from V1 to V3 is 73. Yeah, that's done. Distance from V1 to V2 has already been found out. Give an answer to the nearest degree. So basically, we are going to use trigonometry in order to solve this question. Now, it's very easy to find the angle given that you know all three sides. We can use the cosine rule for that, but I don't really know this distance over here from V3 to V2. So first of all, I'm just gonna quickly find out this distance from V3 to V2 and then plug all of these three distances into the cosine rule formula. Let's try to do that really quickly. So I am going to speed through this because the concept is really easy. It's just a repetition of the distance formula that we studied, and let's move forward. So the distance between the x, so the difference in the x coordinates is basically -5 and 2.5. That is going to be a 7.5, and the y coordinates distance is going to be 5. 7.5 and 5. So part number E, let's first find the unknown distance over here, and that is going to be found by the difference between the x coordinates. That's like a 7.5 square plus a 5 square. And if I do the math really quickly directly, this is going to give me an answer of 9.014, which obviously I would need to multiply by 100, so it's going to be 901.4 meters. It's a good idea to have in the decimals because there's no condition on me now to have it as whole numbers. Now with this value inserted into my diagram, which is going to be 901.4, this is simply found out as 901.4, and now I can use the cosine rule to find out the angle. Now the cosine rule basically means for the angle you have a different version of the cosine rule. It's something like a cos of c is equal to a square plus b square minus c square over 2ab, something like that. So you need to refer to your formula booklet to actually note down the formula correctly so that you don't make any mistakes. So I'm gonna directly write down the formula. It's gonna be cos of the angle theta is equal to, let's make a fraction and write down our formula. That is 1265 square plus 783 square minus 901.4 square divided by 2 multiplied by 1265 multiplied by 783. Let's try to find out the answer of this directly. So cos of theta is basically gonna give us an answer close to 0.7071, and obviously by taking the cos inverse of this we are going to get our final answer of the angle, and that should be close to a 45 degree. Okay, let's jump into the final part of this question. It is going to be hence find the area of the Voronoi cell containing hotel D, giving your answer in meter cube, meaning we need to use all the distances that we multiplied by 100 obviously. So what's the area of the cell containing hotel D? So it's actually focusing on this triangle. He could have said it, find the area of the triangle containing point D, but obviously it's a Voronoi diagram question. For the IBDP AI students, you need to be comfortable with the lingo or the terms used in this question. So in short, find out the area of this triangle. It's not a right angle triangle, so I can't really use half into base into height. I need to use the formula of area of a triangle derived from the sine rule, which is half multiplied by a multiplied by b multiplied by sine of the angle in between the two sides. So look for two sides and the angle in between them, and I luckily have all of these things with me on the diagram labeled, so I can directly apply the formula and get my answer. Half multiplied by 1265 multiplied by 783 multiplied by the angle in between them, which is sine of 45. Alright, so let's jump into part number F, and that is simply going to be our final answer. So area is going to be equal to half AB multiplied by sine of C. While writing the formula does not really do any good, but I'm just writing it for remembrance over here. So the first length is going to be 1265, the second length is going to be 783, and the third is going to be the sine of the angle in between these two lengths, that's a sine of 45. Directly finding the final answer, 350,000 meter square, and that is the area of this triangle. This basically completes our question on Voronoi diagrams and basically a lot about coordinate geometry in general, because Voronoi diagram is a topic along with perpendicular bisectors which is heavily dependent on coordinate geometry. All the best.